Okay, so we just looked at addition and subtraction word problem types. So in this video, we're going to look at multiplication and division word problem types. So again, with multiplication, let me lower my camera a little. With multiplication, if we think of just a basic multiplication problem, so let's say like 3 times 2 equals 6. One important thing to know when we are doing multiplication is that we multiply in a very specific order. So the first number always tells you the number of groups you have, and our second number always tells you the size of the group. Okay. So in this particular problem, I have 3 groups of 2 things. So if I were to draw a picture, that would look like maybe I have 3 boxes and each box can hold 2 cupcakes. And then the question would be, well, how many total cupcakes do I have? So I have 6 cupcakes, which is our whole. Now, so what is important about this is if I flip this around and make 2 times 3, the answer is still going to be 6. But what's important to know is this is a different situation. 2 times 3 would tell us that we have 2 groups of 3 things. So if I were to draw a picture of this, it would look something like I have 2 groups. So maybe I have 2 boxes, and each box this time can hold 3 cupcakes. So I still, again, have a grand total of 6. But it's important for little kids to realize that these are different situations. Having 3 boxes of 2 would be different than having 2 boxes of 3 of something. Okay? So that'll be important as we're going through this class to remember that distinction. Okay, so again, when we have a fact family, just like we did with addition and subtraction, in terms of word problems, I could give a word problem where I am just looking for the whole. So like I have 2 boxes and 3 cupcakes per box. How many do I have total? I could ask you a problem where I don't know the size. So maybe I have 2 boxes. There are a certain number of cupcakes in each box. If I have 6 cupcakes total, how many are in each of the boxes? Or I could ask a question where I do not know the number of groups. So I have some number of boxes. There are 3 cupcakes per box. So if I have 6 cupcakes total, how many boxes would I need to equally divide those? Okay, so just like before, anytime you have a multiplication problem, there are 3 different ways you can ask an unknown. So actually, there are not really any division word problems per se, but they are all multiplication. But some of these you may actually solve by doing division. So maybe in school you were taught, in order for this one, instead of thinking 2 times what number gives you 6, you are more than likely in your mind going to say, okay, 6 divided by 2 equals 3. Or same thing down here. Instead of telling yourself, okay, what number times 3 makes 6, a little kid may say, okay, if I take 6 divided by 3, that's going to make 2. Okay, so that's where division comes into play. Some of these you might be solving through division. Okay, so if you look on page 47, so I'll show you the page number 47. We have the different types of problem structures for multiplication. So there's really only 2 different types. Well, there's 3, but we're not going to talk about the third one. The third one is combinations, but we're not worried about combinations. So we're just looking at 2 different types: equal group problems and comparison problems. So with equal groups, there are kind of 3 different ways to think about equal group problems. So equal groups just means you're making groups of the same size of things. So equal groups could be in terms of objects, so like this is bags and apples, you could make equal groups or equal piles of money. So 5 apples, 4 cents a piece. So in problems involving money, equal groups of money. Or you can think about distance. So walking 5 hours at 4 miles per hour. So grouping distance together. So those are examples of equal groups. Okay, so when we're doing equal group problems, again, there are the 3 situations that you could possibly have with the missing quantity. So the first one is where we know the number of groups, we know the size, and we're looking for the whole. So 4 bags of apples, 5 apples in each bag. So 4 times 5, so 20. The second one is known as size of groups unknown. So we know the number of groups, but we don't know how many are in each group. And then we know the whole. And then the final one is not knowing the number of groups we have, but we know how many are in each group. And then we know the whole. So these are the ones where I said you might be solving them by doing C divided by A, in this case, and then doing C divided by B for that one. So later in this class, we will talk about, this would be 2 different ways to think about division. So we are either doing partitive or partition division, or we are doing measurement division. So like I said, we will get to that another time. So not the focus of this video today. And then the other thing that we care about are comparison problems. So in comparison problems, again, either the product is unknown, the set size is unknown, and then in this case, instead of thinking of groups, it's the multiplier. So comparison problems, an example would be, we'll just read one. So Mark picked 20 apples, Jill picked only 4. How many times as many apples did Mark pick as Jill? So someone is getting 2 times as many, 3 times as many, 4 times as many as somebody else. So that is the multiplier. So instead of necessarily thinking of, where did I put my paper? So instead of necessarily thinking of number of groups and size, we have now the multiplier and still compared to the size. So I picked 3 times as many apples as you did. So if you picked 2, if I did 3 times that amount, then I picked 6. So that would be an example of the multiplier. Okay. And with comparison problems, we typically see comparing quantities of objects. So like Jill having a certain number of apples and Bill having a certain number of apples. Or again, you can think of in terms of money. So someone has twice as much money as you, or 3 times as much money as you, whatever, 10 times as much money as you, whatever it happens to be. Okay. So let's take a look then at some examples. So page 45, and it goes on to 46. So maybe again, if you could take a minute and try these out. It asks you to draw a picture. You don't necessarily have to do that, but if you do write an equation that models the problem, that would be great. So what situation is going on here? If you want to draw yourself a picture, go ahead, but see if you can identify the word problem type. Is this an equal group problem or a comparison problem? And then what is the thing that's unknown? Do we not know the whole? Do we not know the size? Do we not know the number of groups? Do we not know the multiplier? So take a minute to try those out. Pause the video, and when you are done, unpause it, and then we can check our answers. Okay, so let's check our answers. So for number 1, Jean has 4 tomato plants. There are the same number of tomatoes on each plant. Altogether, there are 20 tomatoes. How many tomatoes are there on each plant? So writing an equation may help you. So, and then also this is why I asked you to draw a picture. So if I just draw kind of what we have. So let's pretend these are four tomato plants. We have the same number on each plant, but there's a total of 20 of them. So we have 4 groups, 4 plants of how many per plant would give you a total of 20 tomatoes. Okay, so this would be an example of equal groups, since we're not comparing. It's not twice as many, 3 times as many. And then the thing we don't know is the size of the groups. Okay. Now, you do not need to tell me like this is an example of equal groups objects or equal groups distance or equal groups money. Those I was just giving you an example of the types of problems that you might see. So this would be an object problem, but it's equal groups. Okay, number 2. Ellen walks 3 miles an hour. So how many hours will it take her to walk 15 miles? So let's think about what she's doing. So 3 miles an hour. So we're going 3 miles, 3 miles, 3 miles, 3 miles, 3 miles. And then that would be the grand total of 15 miles. So how many groups do we have right there? We have 5 groups. So it would be like 5. Oh, but that's the thing we're solving for, right? So how many hours if she goes 3 miles an hour? So that's each hump is 3 miles. So that's the size. If it was a total of 15. So this is equal groups. And in this one, it is the number of groups. I'm going to shorthand this. Number of groups is unknown. Okay. So she did 5 hours of 3 miles per hour. Okay. For number 3, pies cost $4 each. How many pies could you buy for $28? Okay, well, so pies would be like the groups, and the $4 would be like the size. So you would do like $4, $4, $4, $4. So 4, 8, 12, 16, so 20, 24, 28. Okay, so that's the size. So how many pies at $4 each would make you spend $28? So the answer would be 7. So this one is equal groups again. And in this one, we don't know the number of groups. So the pie would be like the group. So the number of groups is unknown. Okay. All right, what about number 4? A giraffe is 18 feet tall. She is 3 times as tall as a kangaroo. So how tall is the kangaroo? Okay, so for this one, I'm going to cheat. I'm not going to draw a giraffe, but here's the giraffe. It's 18 feet tall. And then it says she's 3 times as tall as the kangaroo. So if we stood some kangaroos on each other's shoulders, it takes 3 of them to be the same size. So for this one, 3 times the height of the kangaroo, which is the thing we don't know, is equal to the height of the giraffe, which is 18 feet. So we would have 3 times something equals 18. Okay, so this one is a compare problem, since we're talking about 3 times as tall. And what do we not know? We do not know the size of the kangaroo. So set size is unknown. And again, you don't have to tell me if it's objects or money, just whether it's equal groups or comparison. Okay. Number 5. Jade has, 4 tomato plants. So here we go again. 1, 2, 3, 4. There are 6 tomatoes on each plant. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How many tomatoes are there all together? So we have 4 plants with 6 per plant is a grand total of how many tomatoes. So this one is equal groups. And let's see, we do not know the whole, the final total. So whole is unknown. Okay. Number 6, Jan bought 7 pies. So 1, 2, 3, 4, 5, 6, 7. She spent a total of $28. If each pie costs the same amount, how much does one pie cost? So we have 7 groups. We do not know how much money each group costs, but we do know we spent a total of $28. Okay, so to solve this one, a little kid might do like 1, 2, 3, 4, 5, 6, $7, 8, 9, 10, 11, 12, 13, $14, 15, 16, 17, 18, 19, 20, $21, 22, 23, 24, 25, 26, 27, $28. So then you can see each pie is going to cost $4. So that's the size. So this one is equal groups with the size unknown. Okay. All right, on to the back. Let's see. Oh, we got 6 more. Okay, halfway through. So pies cost $4 each. How much do 7 pies cost? So again, so 1, 2, 3, 4, 5, 6, 7 groups, $4 a piece. So 7 groups at $4 a piece is how much money total? So this one would be equal groups, where we do not know the whole. Okay, whole unknown. Number 8, Jean had some tomato plants. There are 6 tomatoes on each plant. Altogether there are 24, so how many tomato plants does Jean have? Okay, so in this one we know the size, so we would do like 1, 2, 3, 4, 5, 6. That has to be a plant. 7, 8, 9, 10, 11, 12. There's a plant. 13, 14, 15, 16, 17, 18. There's a plant. 19, 20, 21, 22, 23, 24. There's a plant. So how many plants have 6 tomatoes apiece in order to have 24 tomatoes? So this one is equal groups, where, let's see, the number of groups is unknown. All right. Number 9, here's the giraffe again. So giraffe, 18 feet tall. Now we know, so let me put 18. So 18 feet tall. We got a kangaroo, 6 feet tall. So the giraffe is how many times as tall as the kangaroo? So how many times would we take the kangaroo's height in order to equal the giraffe's height? So here is where we do not know the multiplier, how many times more it is. So this is a compare problem. So in this one we don't know the multiplier. So multiplier is unknown. So we know the answer is 3. It's going to take 3 kangaroos to make a giraffe. Okay, number 10. Ellen walked 15 miles. Okay, so let's say, so she walked 15 miles. It took her 5 hours. So we know we have 1, 2, 3. So chopped into 5 sections. So 1 hour, 2 hour, 3 hour, 4 hour, 5 hour. So if she walked the same speed the whole way, how far did she walk in 1 hour? So we have our 5 groups, the 5 hours. So how much is in each of those groups? In order to make a total of 15 hours. So this one would be equal groups, where we don't know the size. So size unknown. And then you could count. So it'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We are on a number line. Okay. Number 11, Ellen walks 3 miles an hour. How many miles does she walk in 5 hours? So again, 1, 2, 3, 4. There's the 5 hours. So she's walking 3, 6, 9, 12, 15. So we're trying to find the total. So 5 hours at 3 miles per hour is something. Okay, so this one is in equal groups where we do not know the whole. So the grand total distance. So whole is unknown. And again, it's 5 times 3, not 3 times 5. 3 times 5 would mean she walked for 3 hours and she was able to do 5 miles in 3 hours, which is a different situation. Okay, and then finally, the giraffe in the zoo is 3 times as tall as the kangaroo. So we know here's the giraffe. There's a kangaroo, and a kangaroo. We know the kangaroo is 6 feet, so we're trying to figure out how tall the giraffe is. So it takes 3 times the height of the kangaroo, which we know is 6, would equal what height for the kangaroo? So we know the multiplier and the size, so we don't know the product. So in a multiplication problem, the answer is the product. Okay, so for comparison products, so for comparison problems, instead of saying whole, we say product. So I should have mentioned that earlier. So product unknown. Okay. All right, so hopefully you got those right when you were checking your answers. So now you have actually 2 homework assignments related to this activity. So first of all is page 49, and then there's also a couple on the back on page 50, so make sure you do those. And then I have some additions to this. So let me zoom out a little bit. I don't know how well you can see this. So first of all, remember I said that there are actually a third kind of multiplication problem that we're not going to talk about, which are combinations. So number 6 and number 9 are combinations. So a combination is where you, that's like putting items together. So for example, if you had 3 shirts and 4 pairs of pants, how many outfits could you make? So each shirt could pair up with each pair of pants. Or maybe you've heard of it in terms of like Subway sandwiches. Subway has like 5 kinds of bread and 6 kinds of meats and 4 kinds of cheeses. So how many total sandwiches can you make? So you just multiply all those together. So we're not focused on that. So go ahead and skip number 6 and 9. And then for number 5, I didn't give you enough information to actually solve this problem. So in number 5, you just need to know that there are also 25 students in the class. So once you know there are 25 in the class, you can solve this problem. But for page 49 and 50, again, you are going to be identifying the problem type. So is this an equal groups or a comparison problem? And then what is the thing that's unknown? Is it the whole, the number of groups, size of the group, product, multiplier, whatever it happens to be? And then write your number sentence. So the number sentence is just this sentence that we had with the question mark. So like something times 6 is 24, something times 6 is 18. So that's what I mean by number sentence. Okay, so you're going to do that page. And then the other thing I want you to do is, now that we are completely done talking about word problems, I want to give you the chance to write your own word problems of a particular type. So this is page 57. And again, since we are not focused on combinations, you can scribble that one out. You do not have to do the last one. But see if you can write your own word problems based on the type. So write me a separate start unknown problem, and write me a compare with the difference unknown. Write me a comparison with the product unknown. So this is a combination of the addition, subtraction, multiplication, and division. So, all right, if you have any questions, please let me know. Thanks.